So up to this point in application-centric infrastructure, we talked about the structure of the different objects and how the policies fit together, and then also how we can configure layer 2 access ports by going through the wizard that create the interface port channel, virtual port channel wizard, and then also how this is binding to the tenant configuration, both the tenant networking, which is going to contain the VRFs, the bridge domains, the subnets, and then also the tenant policies, which is going to contain the application profile, which has the endpoint group, which has the contracts, which has the subjects, the filters, ultimately controlling how traffic is going to enter and exit the fabric. Now, in most typical deployments, when you're not doing a greenfield implementation, so assuming that the network is already in existence and then you're using ACI, but you have to migrate your previous services into the fabric, that's where we're going to have this situation here where we're connecting our traditional layer 2 network via typically Ethernet trunk links. And then we are taking our previous servers that were maybe connected to Nexus 7K, 5K, 2K, or maybe Catalyst 6509, something like that. And then we need to either permanently or temporarily just get connectivity between the two segments of the network, the ACI and then classical Ethernet, in order to do essentially the migration into ACI. So we're going to look at a couple different variations of this. And the main thing, again, to be aware of here is how the different objects fit together within the ACI workflow. And then we'll see what are the different ways that we can connect the layer 2 networks, either with just extending the endpoint group or the EPG out of the ACI fabric, or using what is called the external bridge domain or the L2Out, which is essentially just a normal classical Ethernet trunk link that is attaching to the Ethernet switches or the Ethernet routers. Now, in terms of some recommended resources for this, if you just search the term ACI L2Out, okay, L2Out is all one word, letter L, number 2, O-U-T. There's this document here that is connecting application-centric infrastructure to outside layer 2 and layer 3 networks. And then this is basically going to be our main focus for today. We're first talking about layer 2 and then also going on into to layer 3 connectivity. Okay, specifically, we have this section here towards the bottom that says layer 2 connections to the outside network. And then there's two different variations that they're talking about, which is just extending the endpoint group out of the fabric and then extending the bridge domain. The second of these is considered an L2 out, which you essentially have the option to do in either design. Both of them can work simultaneously. It just really depends on whether you want to apply a contract between the previous portion of the network that's attached to your classical Ethernet and the new portion of the network that is going to be connected by ACI, and then how granular you want to get in your policy application. Now, as we talked about briefly before, a lot of the implementations today with ACI use what's called a network-centric implementation as opposed to a policy-centric implementation, where network-centric is we're basically taking our previous constructs that we had in classical Ethernet, things like our access VLANs, our trunks, our VRFs, our regular layer 3 routing protocols like OSPF, BGP, etc. And we're basically just trying to map those constructs on a one-to-one basis over to the ACI without having to deal with all of the policy implementation in terms of the contracts and the implicit deny behavior of the fabric by default. Because moving from an implicit permit to an implicit deny is a pretty big migration process. You'd have to know how every application is talking to each other. And a lot of times it's not very easy to map those out, or at least not very quick to map those out, where we can start with just a traditional type network design where you permit IP-any, and then we can selectively deny flows. We'll see by what is called a taboo contract, okay, where a normal contract is basically an explicit permit, and then a taboo contract is an explicit deny. Same as a normal access list, is where if you think about a typical switch or router, any traffic that comes in is going to be permitted, typically by default. Where you compare this to a firewall normally is going to deny traffic. So in a firewall, you would have explicit rules permitting traffic and then land an implicit deny. Where with a normal router or switch, you would have explicit deny rules and then end in an implicit permit. Okay, and that's ultimately going to be the difference between the normal contract and the taboo contract. So normal contract is going to be for implicit deny, and you are whitelisting traffic, taboo contract is going to be for implicit permit, and then you're doing explicit denies before that. Okay, so we'll look at both variations, but the key here is that when you're doing this implementation for the first time, if it's not working, like you can't get connectivity between the endpoints, you want to make sure that you fall back to the simplest design, which is basically to permit all traffic and then figure out, is this some sort of problem with my policy application, like in terms of how the different objects are fitting together, as opposed to going the full-blown policy-based implementation, which would have to have the different endpoint groups and the contract subject filters, et cetera, applied onto to every single application. Okay, so that's going to relate to these two here, which is to extend the EPG out of the fabric versus extending the bridge domain out of the fabric. So if we look at the difference between the two of these, and we're going to go through the config, of course, on a step-by-step basis, they give a kind of a comparison between the two of these side by side. So the use case of extending an EPG is, it says extend EPG beyond ACI fabric, extend VLAN represented by EPG out of the ACI fabric. So this in and of itself is not very descriptive, like a lot of the documentation on the ACI. But basically what this means is, let's say that you have a web server that you have inside of your fabric, okay, and you have that web server in VLAN 10. You also have VLAN 10 in a portion of your classical Ethernet network. And you have other devices that you want to put on the same IP subnet, you want to put them on the same VLAN, and you want to get IP connectivity to them. So instead of applying two separate endpoint groups, which would normally require a contract between them in order to permit the traffic, what you can do is simply assign the endpoint group to the port going towards the switch, specify what the VLAN encapsulation is, like in that case VLAN 10, and then the web server that's inside the fabric and the devices that are outside of the fabric, they're treated as if they're in the same endpoint group. Well, technically they are in the same endpoint group, and the end result is that you are permitting traffic between all the devices within that particular endpoint group. So you don't need to do any filtering in order to allow the traffic. Okay, the second variation, which is extending the bridge domain, is that we will need to apply a policy between the two. And really it's going to be this fourth row down here, which is going to be the main difference we'll see in the implementation, is that if you extend the EPG out of the fabric, you don't need to apply a separate policy, okay, because it's going to use whatever policy that you already have applied to that endpoint group. But if you apply it by extending the bridge domain, which is going to be with the L2Out connection, the L2Out VLANs are going to be categorized in separate endpoint groups, which means that you will need to apply a policy, basically a contract, which has the filters that are saying in order to get into the web server inside the fabric, you need to permit TCP port 80, you need to permit TCP 443, whatever specific traffic that you want to allow. Otherwise, by default, with the implicit deny or the whitelist model, it's going to be dropping all of the traffic. Okay, so we're going to first start with the first variation, which is just extending the EPG, and look at how that's going to affect the traffic flows, and then we'll look at the second variation, which is doing the L2Out, which is creating the external bridge domain. Okay, so first off, let's talk about what is going on in the topology to begin with. So in classical Ethernet, I have the network partially pre-configured, where we have server 1 is going to be in VLAN 1002. Okay, server 1 is using the physical link that's going up to 5K1, and it has the subnet 10.0.2.0/24. Okay, its address is .11, and its gateway address is .254. Okay, so the .254 address, this is going to exist inside the ACI fabric. We're going to configure this as essentially an anycast gateway, which is what you define when you create the subnet under the bridge domain. So recall back to our VXLAN BGP EVPN config on the standalone NXOS modes. We created the normal SVI interfaces like interface VLAN 1002. We gave it an IP address, but that IP address was the same number that was configured on all of the 5Ks, all of the leaf switches. Then when the end host goes to ARP for the gateway, the leaf switches were replying back with the same MAC address. So this means that if you do a virtual machine mobility, like a vMotion from one leaf over to the other, the end host application doesn't need to update its IP address, it doesn't need to update its gateway, and most importantly, it doesn't need to update its ARP cache so it can continue to forward layer 2 and layer 3 traffic as if nothing happened, that the vMotion or the workload mobility is going to be completely independent or completely transparent from the end application's point of view. Okay, and we'll see when you configure the subnet in ACI, you can also choose whatever particular MAC address you want, which is going to be the logical equivalent of the Anycast fabric forwarding MAC address that we had manually defined in a global config of the 5Ks when we were doing the VXLAN either flood and learn or the VXLAN BGP type config. Okay, then over on server 2, server 2 is going to be using its link over to 5K2. This guy is going to be in VLAN 1003. Its IP address is 10.0.3.0/24. Its end host address is .12, and then likewise the gateway address is .254. Okay, then we're going to be layer 2 switching the traffic up to the 7K. So these are going to be just normal trunk links. Okay, there's nothing special about this config. We just say switch port mode trunk, no shutdown. And then the 7Ks, I have them pre-configured in a VPC domain. Okay, so we have the VPC peer link that's running between the 7Ks that's going to be synchronizing the control plane between them. I have the keep alive going over the management interface. And then for the member ports, I don't yet have that configured because we're going to come back to that a little bit later. Once we look at the first variation of extending the EPG out of the fabric, then we'll look at the layer 2 out, which is going to be the external bridge domain. Once we get to the point that we have connectivity, then we'll look at how spanning tree protocol is interacting from the external switches into the ACI fabric. And then finally look at a back-to-back VPC configuration between the 7Ks and the ACI leafs, which is going to allow us to do active-active forwarding, which is typically what we would want as we're trying to migrate from classical Ethernet into the ACI fabric. Okay, additionally, we have 7K3 and 7K4, which are connected to the ACI leafs, and we're going to be using these as essentially endpoints, basically like servers. So on 7K3, on this port, I have it configured as a native layer 3 interface, and it has the IP address that is 10.0.1.73/24. And I have a static route, okay, static default route that is going to the gateway address of .254. Okay, so we're basically going to say that this guy is essentially going to be our web server. You know, when you're testing this out, if you don't have actual end applications to test web services like Apache, you know, Microsoft IIS, whatever, you can turn on the Nexus API. So it's feature NX API in global config. And then you can also turn on the NX API sandbox, which actually is a web server on the NXOS box. And then you can interface to it through, you know, Chrome, Firefox, Internet Explorer, whatever web browser that you're using. So we are going to be doing actual regular HTTP calls to make sure that the policy is actually applied as if it was a normal, you know, production web server like Apache web server. Okay, so then our first step here is we're going to basically start with a blank config on the fabric, with the exception of the leafs and the spines have already been discovered. Okay, so we already have the node IDs configured, which means on the back end they've already created the infra VRF, which is where they're running ISIS routing, they're running multicast in order to build the underlay for the fabric. And what we're now going to be doing is creating the overlay, which is essentially the VXLAN tunnels. They're going to go from leaf to leaf in order to either do our layer 2 bridging, okay, so layer 2 VNIs over VXLAN, or our layer 3 routing, which would be our layer 3 VNIs over VXLAN. Okay, so before we make any changes here, let's go ahead and do some basic verification. So let's start on 7K3. And on 7K3, let's just look at the show IP interface brief. And we have our interface connected to the ACI leaf. This is going to be leaf 101. Address, like I mentioned, 10.0.1.73. So the VLAN number here, I'm encoding in the first 3 octets, where this is VLAN 1001. Okay, so 10.0.1. If we look at the routing table, show IP route, we have a static default route going to 10.0.1.254. So we're going to configure this as the subnet, is essentially the Anycast gateway inside of the ACI fabric. And then ultimately what we're trying to do is to get at least basic IP connectivity from the leaf going over to the, or from the 7K3 going over to the leaf. Okay, so actually I was testing this before. I already have this pre-configured. So what I'm going to do now is let's go over to the ACI. Okay, so I'm going to log in as admin. and I'm going to roll my config back to a snapshot that I had taken where the fabric is a bit, essentially a blank config. And this is one of the quick ways that you can change between configs on the ACI, as opposed to like doing a write erase, reload, and then copying the config in as you would do on your normal Nexus boxes. So if we look at currently under tenants, we have the tenant INE, which was the one that we were doing in our previous examples with the layer 2 access ports. So what I'm going to first do is go under the admin tab, and then under config rollbacks, there is this default snapshot. It was the first one that I had loaded onto the box before we started our previous configs. And then you just basically select whatever snapshot that you want, click on rollback to this config. Do I want to roll back? Yes. And then you'll see next to the config, there should be a green checkbox that comes up here. This will tell you that the process is complete, okay, which is here. Okay, so if we go over to tenants, we can see now tenant INE is deleted. Okay, so it's basically back to the blank config where it has the 3 default tenants. So one for the shared routing table, which is common, one for the underlay, which is the infra or the infrastructure, and then one for the in-band and out-of-band management, which is the management MGMT tenant. Okay, additionally, if we look at the CLI, so I have the connection open to, the APIC. Let me reconnect here. And again, from rack rentals, the easiest way to do this is just to use one of your 5Ks or 7Ks as a jump box. So from them, SSH to the IP address of the APIC, which in our case is 192.168.0.4, and it's in the out-of-band network, so it's in VRF management. Okay, then log in as admin or log in as Cisco. You know, the credentials would be provided in the case of the rack rentals. But so here we're landing on the CLI of the APIC, and we're going to just show run. Okay, what we're looking for here is basically the config of the leafs. So if we go down towards the bottom, what we would normally see above the kind of the management stuff, which would be like the snapshots, there would be between our tenants and then whatever the monitoring and stuff is. This is normally where the layer 2 and layer 3 configurations would be for the application to the physical ports of the leafs. So we'll see a little bit later, we're gonna look at the result of the CLI after we make the changes from the GUI, and then look at how we can actually make those changes from the CLI and then build a configuration like we would normally do on standalone NXOS. So if you don't want to call the APIs on the box, you can basically just create normal templates of config like you would on your traditional network boxes, and then just copy and paste that into to the APIC. Then the APIC is going to push those changes down to the leaves or the spines, whatever the actual changes that you are making are.